example number 9. This problem relates to the factor theorem. So given the polynomial, what are some potential factors? So this is relating to the factor theorem. The factor theorem has to do with the whole number or the integer factors that we get from the minus 4. Okay, so we get plus minus 1, plus minus 2, plus minus 4. And then we have our factors from here, which give us the rational factors. Okay, and so the potential factors then become, we have list all our integer factors, and then we have all our rational factors when we divide by, well, 1, but those are just going to be repetitions, and the one we divide by 3. Okay, so this is our rational root theorem and our factor theorem. Okay, these ones give us our integer ones, and dividing by the leading coefficient gives us our rational factors. So these are what we would consider as potential factors. These are not the factors, but the ones we would test. Okay, so these ones here we talk about looking at getting the graphs. So here, what would a graph given this information look like? So we have 3 zeros and a negative leading coefficient. We're going to assume this is a cubic function. Okay, so we have solutions here at 2, negative 2, positive 2, and 4, and it's a negative coefficient, so we know that as a cubic it's going to go down in this way. So it's going to have to go through the zeros in this kind of pattern. Okay, so that's one possibility. Okay, where the vertices are, we don't really know because we don't know exactly how high these are going to go. So this is going to be a problem, but this is something we can't resolve in pre-calc 12. We have to wait till we get into calculus to do this. Okay, and then this last one here, we have a double root at negative 2 and a root at x equals 3, and a non-real root with a positive leading coefficient. So this means that we have 2, 3 non-real roots come in pairs. So I'm just going to say I have 2 degrees here, 1 degree here. The non-real root must come in pairs, so this 5th degree polynomial. It's a leading coefficient that's positive, so I know it's going to be sloping up. Okay, so to draw this, we know that it's going to touch here. It's got to go through the root here, going in this direction, and we have to have a non-real solution somewhere. So that non-real solution we can put anywhere because we can't really find that non-real solution at this point. Okay, so that non-real solution is going to be that little bump there. Okay, so that's going to be the non-real root, and there's 2 arms involved because these non-real roots must come in pairs.